Alright guys, what's going on today? We will be finding the centroid of two shapes today. We'll be finding the shape of this rectangle, and then we'll be finding the shape of this L. So to start with finding the centroid of a rectangle, you have to find where the axis of symmetry lies on both the x and y direction. So for the x direction, we'll label the axis of symmetry as x1, and the y1 similarly for the y direction. So in order to find where x1 and y1 lie, you take where the axis of symmetry lies, and we will start from the origin point. So x1 is equal to 40 millimeters, since that is half of 80. y1 is equal to 10 millimeters. And in order to find the centroid, you use the formula x bar equals x1 times a1 divided by a1. X bar equals 40 millimeters, since the a1s cancel out. This formula is more often used in composite body areas. So similarly, y bar equals 10 millimeters. Next, we will look at the L shape. As you can see, we have segmented the L shape into two parts, 1 and 2. 2, we have just found where x bar 1 is equal to, I should call this x bar 2. We found this earlier. X bar 2 is equal to 40 millimeters. And similarly, y bar 1, I'll draw it on this side, save some space. Y bar 2, y bar 2 is equal to 10 millimeters. And now for section 1, it is equal to half of 80 minus, it is half of 60 plus 20. So y bar 1 equals 20 plus 80 minus 20 divided by 2. Y bar 1 is equal to 50 millimeters. X bar 1 is equal to 10 millimeters, since that is half of the axis of symmetry of shape 1. So now, in order to find the centroid of this composite area, we will use the formula that we previously used. X bar equals x1 times a1 plus x bar 2 times a2 divided by a1 plus a2. So x bar is equal to 10 times 20 times 60 plus 40 times 20 times 80, all divided by 20 times 60 plus 20 times 80. So x bar 1 is equal to 27.14 millimeters. And if we follow a similar calculation for y bar, it is equal to 27.14 millimeters. And both of these measurements are taken from the origin point